One of the practices I think is really important when looking at the balance between complexity, cost, and the high availability software is keeping everything in perspective. A lot of times companies might look at the cost of downtime as lost revenue, but there's many more factors that will contribute to the cost of a downtime. There's the cost of employee hours to bring the systems back up and return operations to normal. There's the cost of employees task switching, whatever they're not doing, which would be generating revenue while they're fixing systems. There's the factor of business reputation. When there are outages, that's something that really sticks with a business and could impact revenue long after an outage is even resolved. And for that reason, I think that when you look at the cost and the complexity of a high availability configuration, keeping perspective on the factors that play into the cost of a downtime and the factors that can affect a business going forward, it starts to become much more reasonable to work towards this very high level of high availability.
Hi, this is your host Saptil Bhartia and welcome to another episode of Data Driven. And today we have with us once again Philip Murray, software engineer at SIOS Technology. Philip, it's great to have you back on the show.
Thank you. It's great to be back.
And today we are going to talk about some of the common mistakes that organizations often make when it comes to high availability and disaster recovery software. We'll talk about how they can plan high availability disaster recovery environment and how to ensure business continuity. But before we deep dive into this topic, of course, you and I have talked about it a lot, but it's always a good idea to refresh our viewers' memories. Please explain the concept of disaster recovery, what it entails, and how it's different from the traditional approach towards disaster recovery.
Disaster recovery is, simply put, making sure that important systems continue running even in the event of a disaster. And when we look at a more modern approach to disaster recovery as compared to traditional approaches, that comes with the introduction of redundancy. In a traditional approach, in the event of a disaster, there would typically be some sort of manual recovery of systems. Applications would need to be manually restarted. Systems would need to be manually booted if they were down. And that procedure is lengthy and it's also risky because you're relying on that singular system and it could be an opportunity for more errors to happen during the disaster or the recovery from the disaster. Whereas a newer model of disaster recovery uses software to orchestrate applications and replication to manage data, and by virtue of having a standby system, there is no need to, on the fly, recover a system and make sure that it's back up in working order because that standby system has access to the data, can start the applications, and can ensure the business continues operating while the other system is resolved. And as a result, this newer approach leads to a much faster recovery time objective and a much faster recovery point objective, being both the time that a system or a utility is down and the amount of data that is lost in recovering a system that has been down.
Thank you for explaining that. Now, in your experience, how much are you seeing the organizations are adopting the modern approach, or you see a lot of organizations are still using the older, or we can say the legacy model, uh, where you see they continue to make these mistakes, and we're like, hey, we should fix it.
I will say, by virtue of my position and my job here at SIOS Technology, most of what I see and help with is a more modern approach where there are redundant systems. However, in services that I use, I do see hallmarks of a non-redundant architecture or an architecture that doesn't support a higher availability level of maintenance. One example there might be when outages are planned for maintenance, they typically last 2 hours, maybe more. I've seen my bank go down. I've seen my HSA website be inaccessible for a period of time. And those are typically hallmarks of systems that either don't have a fully comprehensive and fully modernized high availability and disaster recovery approach, or are still using that legacy model where applications have to be taken down or can't be accessible during maintenance, during updates, which results in that downtime for users. A more modern approach might be something where users access a system that hasn't been updated until that has been fully updated. That updated system is brought to production and is accessible for users. And while that production system is being accessed, the standby system is being updated, ensuring that users have full uptime of the service and that updates are performed seamlessly to the user.
When you look at the whole industry, users, customers, what are the most common mistakes that you see organizations make when designing high availability disaster recovery strategies, and how they can avoid these mistakes?
The most common mistake I see is a lack of a QA environment, a lack of a testing environment. More often than not, when customers are using a modernized high availability disaster recovery approach, when they run into issues, it's because they've gone off script, because they're doing maintenance, doing updates, um, doing something extemporaneously without having planned, vetted, and improved the plan before moving forward with the activities. And so for this reason, I really think that the biggest mistake I see people make is having this lack of a QA and testing environment, because it allows you to do a dress rehearsal. If you need to perform updates to your systems, if you need to roll out a major security patch, if you have this standby QA environment that isn't acting as production, then you have the ability to stage a full rehearsal, just like they might do on Broadway, where just like the live patching, the production patching day, you're able to step through the motions and catch any obstacles, catch any sticking points before you start rolling out your changes to a live production system. And this lets you make sure that mistakes aren't made on the production day. The teams that are going to be working on production are very experienced with what's going to be going on, and they aren't surprised by anything that's happened that doesn't appear on their run book. And they can achieve a more successful maintenance, patching, update procedure on their production systems. And when you couple this standby QA environment with the redundancy provided by high availability and disaster recovery software, you also achieve multiple layers of protection. Not only have you practiced the procedure on that QA environment, but having that standby system, being able to patch that standby system while the production still runs, switch over, and then patch the other standby system or the system that was just switched over from. You have multiple layers of protection to ensure that the service remains running and that you're not applying something or moving forward with a procedure that would result in interruptions for your users or interruptions to your service.
But in cases where organizations rely heavily on cloud services, how do they protect against zone or region wide disaster?
Protecting against those zone and region-wide disasters is really as simple as spreading systems out, geographically spacing the sites where applications are going to be running, and replicating data between those sites. I think it's best explained with an example. I'm here in South Carolina. If I host my primary data center here in South Carolina, I might also have a standby data center in California. That way, if there were something that would cause an outage to occur in South Carolina, whether it's a disaster or just network connectivity issues, anything like that, that California data center that I'm also hosting won't be affected by the same outage, by the same disaster. And services applications can all be transferred over to that California data center. Users will see a continuity of service, and I have that time to resolve whatever issue is happening in the South Carolina data center. Um, by virtue of using those multiple zones, multiple regions, you can avoid those disasters. And I'll throw this in as a little tag because it's something one of my professors said and it sticks with me really well. And he always said, space your systems out so if one gets hit by a meteor, the other isn't also hit by a meteor. It's a little bit of a silly example, but it's one of those that once I heard it, the lesson stuck with me.
When it comes to high availability, disaster recovery, building strategies, tools, culture, it can be complicated. It can also be
Mhm.
costly, and companies are becoming very, very cost efficient. They are also looking at simpler solutions. What is your recommendation where organizations can maintain a balance between, of course, no compromises with the high availability disaster recovery, but with cost, complexity, and their business agility, business continuity, how they can maintain the balance?
One of the practices I think is really important when looking at the balance between complexity, cost, and the high availability software is keeping everything in perspective. A lot of times companies might look at the cost of downtime as lost revenue, but there's many more factors that will contribute to the cost of a downtime. There's the cost of employee hours to bring the systems back up and return operations to normal. There's the cost of employees task switching, whatever they're not doing, which would be generating revenue while they're fixing systems. There's the factor of business reputation. When there are outages, that's something that really sticks with a business and could impact revenue long after an outage is even resolved. And for that reason, I think that when you look at the cost and the complexity of a high availability configuration, keeping perspective on the factors that play into the cost of a downtime and the factors that can affect a business going forward, it starts to become much more reasonable to work towards this very high level of high availability. That said, I also, having worked in this industry for nearly 5 years now, I also see that the complexity is lowering every year. We're working on making sure that software high availability is accessible to users, and as a result, the cost comparison makes the high availability software pay for itself, and the complexity element is improving and it's becoming easier than ever to ensure uptime for your applications.
Now, since you're talking cultural part, let's talk about the tool part because culture and tool they go hand in hand. We have had this discussion, without right culture, you can have all the tools, but folks won't use it. Even if you have right culture, but you don't have tools, then what can you do? So let's also talk about tools. Also talk about the role that SIOS plays in addressing some of these challenges that we just talked about.
So some of the tools that SIOS Technology offers are two primary components. There's LifeKeeper and there's DataKeeper. Earlier on, I spoke about the continuity of applications and also the accessibility of data. LifeKeeper ensures continuity of applications, and DataKeeper ensures data is replicated so that data is accessible on any site where applications are going to be started. And these two components help to comprise a very comprehensive high availability disaster recovery strategy. Further, from the perspective of how these tools can weather almost any situation, they've benefited from decades of improvements. I remember I've been looking through some cases and I've stumbled across iterations to the product that started before I was born. And I'm 27 years old right now. So the decades of improvements have ensured that the LifeKeeper, the DataKeeper product have experienced almost any type of environment that you can think of to ensure that improvements are made and they're ready to take on the challenges posed by such an environment, and that the user experience is up to par to ensure that administrators can readily use the software to achieve high availability. That said, if if you want to get the absolute most out of a high availability and disaster recovery strategy, if you're looking for that last tenth of a percent of uptime that you need to ensure that you're meeting your business goals, SIOS also offers health check services where engineers like myself, I've run a couple of these in the past, would look at your systems, evaluate their readiness, evaluate them against known issues or anything that could cause an unplanned downtime, and ensure that your applications are ready to hit the ground running and maintain that high degree of uptime. Additionally, we also offer installation engagements where your team, if your team isn't familiar with the software yet, the SIOS team can help you install your software and help you make sure that everything that you need is in place before going live to ensure the availability of your software. And we also offer training engagements so that if you need to ensure that your team is ready to leverage the SIOS products to the absolute full extent of what's offered, your team is knowledgeable, ready, and can act in a moment's notice to administer the product, administer the solution, and achieve that higher degree of functionality, of performance, and of business continuity from the SIOS products.
Philip, thank you so much for joining me today and talk about, of course, how organizations can further improve their high availability disaster recovery strategies, how to become more efficient and cost effective. Thanks for great insights. And as usual, I would love to have you back on the show. Thank you.
Thank you, and thank you for having me back once again. It's always a pleasure talking with you. Thank you. Have a nice day.